What's a magnetar? What is a magnetar? Well, clearly it has something to do with the magnetic field. And we said that neutron stars have extremely strong magnetic fields. Magnetars are only the fastest rotating neutron stars. Those ones that are close to 1,000 times a second can become magnetars. Because here's what happens. Here we go. Here's what happens, and this will finish us up. The magnetic field of a neutron star that's rotating close to 1,000 times a second has a hard time keeping up with the rotation of the star. And what that does is it causes that magnetic field to get super tangled. And those tangles will actually penetrate the surface of the neutron star. Now, this should all sound familiar because something similar happens on our sun, right? When the sun's magnetic field gets all tangled up and touches the surface, we get sunspots, right? But the surface of a neutron star is weird. What did I say was weird about the surface of a neutron star? What's weird about this surface? That's not true on any other kind of star. It's solid. It's solid. So in the magnetar, when this magnetic field gets so tangled up that it starts coming down and touching the surface, it will actually open a crack in the surface of that star. Now, what do we call it when a crack opens up on the Earth? What do we call it when a crack opens up? Happens in California all the time. What do we call it when a crack opens up? An earthquake. So when a crack opens on the Earth, we call it an earthquake. So if a crack opens up on this star, what are we going to call this? What are we going to call this? Because we can't call it an earthquake because this is a star. It's not Earth. What's this going to be called? That's a starquake. A starquake. Which to me sounds like a good name for a band. Starquake. Don't take it. Don't steal it. I've called Starquake. It's going to be my next band. Starquake. Boom. Now, so magnetars have starquakes because of their magnetic field. Now, that starquake is not going to last very long because the gravity of the neutron star will just seal it right back up. So if you weren't looking at it, it seems like you'd miss it. So why do we care? Well, here's why we care. When that crack opens up, for less than a second, we're able to see under the surface of the neutron star. And what's the temperature going to be like under the surface compared to the surface? Is it going to be hotter or colder inside? Hotter or colder? Hot. And so what will that do to the brightness during the starquake? If you can see where it's hotter during the starquake, what will that do to the brightness? It'll get really bright. So every time there's a starquake on a magnetar, that neutron star will get way brighter than usual. How bright am I talking? Well, that crack lets out in less than a second over 100,000 times the light that our sun makes in a year. So that crack will let over 100,000 years of sunlight out in less than a second. So if you were like looking at the neutron star, it would be sitting there and it would just be, "Dad!" And then it, "Dad!" And then it's going, just, "Ha!" Just, "Hadouken!" And then it closes up. So if you were anywhere near it when the starquake happened, what would happen to you? What would happen to you? Kamehameha. Yeah, this would be able to vaporize whole planets. It would be just gone. Yeah, sorry again about the sound. Yeah, you're not just gonna go blind. You will vaporize. You will be vaporized if you were nearby. Luckily for us, none of these seem to be close to us, so we're not gonna get the whole Earth vaporized by this anytime soon. And the magnetar can just keep doing it over and over again, but it doesn't happen in a regular amount of time like a pulsar, because it's a more you're relying on a tangled magnetic field to do it, and that's chaotic. So it'll be crazy. All right, that's all I have to say about white dwarfs and neutron stars. So next time we're going to start talking about black holes, and you don't want to miss that stuff because black holes are way crazy.